So all of you are welcome in the class mechanical models of viscoelastic fluids or viscoelastic material. Udit Kumar has come. Okay, Udit Kumar, roll number 8. But now you have Father Kumari. एक एक करके आते रहिए, पढ़ाई ना हो पाएगी.
Good morning, sir.
Slow. Presence of the students is not uniform or it is very erratical, and so we are waiting and we are not able to give performance as required. So we will have to understand that type of foods are not. So there are mixed characteristics of the food. That is viscoelastic. Viscoelastic condition is the condition in which the elements are both viscous and elastic properties. Sometimes viscous, elastic and plastic properties का जो संयोग है वो जब देखा जाता है तो इस तरह के फूड को viscoelastic प्लास्टिक फूड कहते हैं. मतलब जिस जब इसमें विस्कस और elasticity का क्या मतलब होता है? Elasticity is the property of the material which shows that when the load is removed, the deformation will be overcome. It will come again to its original position. That is known as elasticity. What do you mean by viscosity? Viscosity means when you apply some load and when load is removed, so it will have some viscous nature. It will have some state which will not come back. That is viscosity. Because of the heat dissipation, some of the molecules will change in such a fashion that it will not be able to recover. That is known as viscous effect. And if it is able to recover, that is known as elastic effect. And the sanyog, the combination of viscosity and elasticity both, is known as viscoelasticity. The time dependency of the stress-strain relationship is the characteristic of the viscoelasticity. The property that exhibits both viscous and elastic properties when undergoing deformation. Such materials are known as viscoelastic materials, and their time dependency between stress and strain is also a characteristic which shows that it will have the combination of viscous and elastic effects. But how much it will be viscous and how much it will be elastic, that will differ from material to material, and it will also differ on the time scale. Whether you are applying the load and considering the deformation in the short time, or you are applying the load for the longer time and looking the deformation for the longer time. The time dependency is also going to decide the components of the elastic and viscous effects. Sometimes the viscous effects is more in case of long time scale. In short time scale, elastic effects are more shown. But I am telling you, try to understand. Who has come? Udit, Kajal, Ravish, Vikas, और कौन है?
Yes, sir.
Ravish, Vikas, Udit, Kajal तो बन गया. So viscoelastic materials have elements of both viscous and elastic properties, and as such exhibit the time dependent strain behavior. These two are very important to write. Other is that exhibit time dependent strain. Elasticity is usually the result of bond stretching along crystallographic planes in an ordered solid. In unordered solids, the bond of the molecules uh, stretching along crystallographic plane, and when it is removed, it will come original in the original form. That is elasticity. And viscosity is the result of the diffusion of atoms inside an amorphous material. Diffusion of atoms inside an amorphous materials. Shivam Kumar. Next, viscoelastic materials will have some great characteristics and some properties, some phenomena. One important phenomena is known as relaxation behavior. And second important phenomena is known as creep behavior. And third important phenomena is known as hysteresis loop. So you can understand that if the strain is held constant, the stress decreases with time. So this is known as relaxation behavior. And if the stress is held constant and the strain increases with time, this is known as creep behavior. And if the cyclic loading is applied and hysteresis occurs between the stress and strain curve, that hysteresis leading to dissipation of mechanical energy. Because why that hysteresis has come? Because of the dissipation of the mechanical energy, the curve which is arising from stress to strain uh, in some time, and when it is coming back, so it is not coming on the same line, but it is making a loop and decreases in the other fashion, like absorption and desorption isotherm. Similarly, here it is the increase in stress is referring to strain, and decrease in stress is not in the same fashion. It because of the heat dissipation of the mechanical energy, and it forms a loop. The effective stiffness depends upon the rate of the application of the load. And synthetic polymers, wood, human tissues, as well as metal at high temperature exhibit these characteristics. Types of viscoelasticity is linear viscoelasticity, non-linear viscoelasticity, and inelastic material. Linear viscoelasticity is when the function is separable in both creep response and load. Why it's separable? It is not time dependent much. Non-linear viscosity is when the function is not separable, which usually happens when the deformation is large. Inelastic material is when the material will fully recover, which is not, which is the case of elastic effect. But if in viscoelastic material is the material which fully recovered to its original state and the removal of load, such viscoelastic materials are known as elastic material and elastic materials. And elastic materials. Viscoelastic foods and elastics to viscous properties. Most solid foods, including cheese, paneer, aged SCM, aged and cooled ice cream, indigenous dairy products, Goa and chana-based sweets, fermented dairy products, yogurts, etc., are viscoelastic in nature. Now, the ratio of the elastic to viscous property depends on the Rishi and Raja. the ratio of how much it will remain viscous, how much it will remain elastic, that will depends on the time of deformation. At short time scale deformation, its behavior is the viscoelastic behavior is elastic, but at long time scales, its behavior is mainly viscous. The deformation remains even after the stress is removed. Now, what are the different mechanical models and mechanical components? There are three mechanical components or the three properties which are which can be joined in different fashion to adjust the property of the viscoelastic material. So three properties are elasticity, viscosity, and plasticity. For elasticity, the model component is the model component is helical spring. The helical spring has load and deflection related as del x is equal to F by E. And for viscous property, the model is dashpot. What is dashpot? You can now see here that in a piston cylinder arrangement, if some fluid is there, so it will move by resisting the frictional resistance of the fluid. The piston will go in the from top to bottom or from bottom to top, and the displacement of the piston delta S by delta T depends on the shear force upon the viscosity. That viscosity is known as lumped parameter, which will oppose the motion. That is known as lumped parameter. Here, the load as related to the rate of change of deflection. लिखिए load is related to the rate of change of deflection by the equation. By the equation. Delta you can take from here. Delta S upon delta T delta S upon delta T is equal to F upon mu S. Mu S. Where is known as lump parameter. Dashpot represents the viscous nature of pure Newtonian fluid. ठीक है, इसी तरह से आप सेंट बॉडी में लिख लीजिए, कहाँ है प्लास्टिसिटी, the model is centiminute body. It represents pure plastic body. It is a weight on plane surface with friction between them and the weight being pulled over the surface through a spring. The component represents elastic behavior as the spring stretches until the friction force is exceeded. The centiminute body is a weight on plane surface with friction between them. Okay, लिखते जाइए, with friction between them and the weight being pulled over the surface through a spring, and weight being pulled over the surface through a spring, pulled over the good morning surface. लगवा लिए, हाँ कल लगवा लिए, हाँ आता है। हम नहीं लगवाए, हम कहाँ लगवाए, इसमें लिखना है कि this component represents elastic behavior. Elastic behavior as the spring stretches stretches until the friction force until the friction force on the surface is exceeded. And the exceeded thereafter deflection continues without the load changing. Such behavior thereafter the deflection continues without the load changing. Such behavior such behavior represents plasticity is represented by the friction. Higher the friction, higher the plasticity. Lower the friction, lower the plasticity. When the friction force is exceeded, then deformation occurs. Here, the component represents elastic behavior as the spring stretches until the friction force on the surface is exceeded. Thereafter, the deflection continues without the load changing. This behavior represents plasticity. Now, the models are, you can see in new slide. Now, first is known as Maxwell model. How? By joining helical spring and dashpot in series and then apply load axially. So here I want to say that when the Maxwell model is there, when a constant load is applied to Maxwell model, instantaneous elastic deformation will take place, followed by continuous viscous flow, which will continue indefinitely as it is not limited by the spring component. When the load is removed, the Maxwell body recovers instantly but not completely. Take a look. When, when a constant load is applied to a Maxwell body, take considerable body, instantaneous elastic deformation will take place. Elastic deformation will take place. ठीक है? Instantaneous elastic deformation will take place, followed by continuous viscous flow. Followed by continuous viscous flow. समझ गए? Which will continue indefinitely. अब ये जो है which will continue indefinitely. Indefinitely, as it is not limited by spring component. As it is not limited by ठीक है? और when the load is removed, दोनों बात लिखनी है. The Maxwell body recovered instantly but not completely. The but not completely. देखा आपने? अब इसके बाद इसमें ये समझना है इलेक्ट्रिसिटी और स्ट्रेस रिलैक्सेशन टेस्ट जो है वो मैक्सवेल बॉडी में परफॉर्म किया जाता है बाय स्ट्रेनिंग ए. दूसरी चीज ये है it represents stress relaxation behavior viscoelasticity. stop here. Time is over.